Hello everyone, today I'm going to talk about the optics of accommodation and range of clear vision. I'm just going to talk about optics of accommodation, not the whole accommodation, because accommodation we will talk about accommodation in case of orthotics, the problems with accommodation, all the components of accommodation, and all these things. I'm just surfacely going to the accommodation, and we will try to cover more about how the range of clear vision depend upon accommodation and how it relates to refractive error. So let's move forward. The first, what is accommodation? It's the dioptric adjustment of crystalline lens for eye to obtain a clear vision for a given target of range. Because uh, accommodation means the power of an eye increases when we accommodate, and at that particular period, the crystalline lens become more spherical, isn't it? That's accommodation. By definition, it's a dioptric adjustment of crystalline lens of an eye to obtain clear vision for a given target of regards. So it's a process by which the refractive power of an eye alters to ensure the clear retinal image. Basically, alters means the power increases. Let's take an example. If eye at rest is 60 diopter, then we want to see 33 centimeter target, then eye becomes 63 diopter or whatever. Increases the power of eye. Basically, by crystalline lens becomes more spherical, isn't it? First it flats and then it becomes more spherical. So that's the function of accommodation, and there is a lot of things in accommodation which I'm not going to cover today. So example, the pathway of accommodation and the different component of accommodation, and there are a lot of things that we have to discuss. But the point of view of optics, we are trying to cover as much as possible, not point of view of orthoptics. So, in an emmetropic eye, the parallel rays of light coming from the infinity are brought to the focus of retina with accommodation is rest, and that's the definition of emmetropia, isn't it? So, this is the definition of emmetropia. But I can also focus diverse rays. If it is for the near object always emits the diverging rays, and I can focus on that. I can also focus on the diverging rays coming from near object on the retina so clearly, which is accommodation. By the help of accommodation, by the help of crystalline lens become from flatter to become more spherical, and the power of eye goes up from 60 to upwards, and the focus is still on the retina, isn't it? Here also from infinity, focus is still on retina, and from near, which is diverging rays, focuses on the retina because with the help of lens, and that phenomenon is called accommodation, which is very simple. So, mechanism of accommodation, just briefly, the ciliary muscles contract and ciliary ring shortens, and equator of the lens move forward, especially front surface of the lens is more curved. As a result, zonules are relaxed and tension in the capsule is relieved, and the lens becomes spherical, or that is convexity, and increasing its dioptric power and allowing near object to focus on the clear retina. So basically, this flat uh, lens becomes more spherical or more convexity, and that's why total power of the eye increases. Total power of eye increases with the help of accommodation. This is the mechanism. So we know this simple mechanism. We have to explain this mechanism with neural conduction, and that's called neural mechanism of accommodation, which is beyond the scope of this video. So move forward. With age, lens fiber and lens capsule lose their elasticity, and the size and the shape of the lens increases, and resulting in the reduction in accommodation. So, finally, lens capsule and the lens fiber become more rigid, so lose their elasticity, and lens become nuclear sclerosis, so hardening, and that's why amplitude of accommodation reduces, and onset of presbyopia, which is approximately at 40s, isn't it? So that condition is called presbyopia, and it's inevitable condition. Everyone has that. So I want to discuss in this slide about the range of clear vision. So this is the picture. This is the let's take example. This is eye, myopic eye of myopic eye of two myopics are, one is 2 diopter, one is 8 diopter. For 8 diopter eye, this is the range of clear vision, isn't it? But for 8 2 diopter eye, this is the range of clear vision. Far point is always 2 diopter, means 50 centimeter, and near point depends on his accommodation. At the same time, for 8 diopter myopic, far point is at 12.5 diopter, but near point depends on that particular patient's accommodation. So it's centrally important to understand for different refractive error, different far point and different near point. For example, let's take an example of one person who is immetropic. Far point is at infinity and near point depend upon his accommodation. If he can accommodate 10 diopter, then his near point is simply 10 centimeter, isn't it? It's simple. If he can accommodate 5 diopter, then his near point is 20 centimeter. If he can accommodate 2 diopter, his near point is 50 centimeter, isn't it? So it's very simple to understand the range of clear vision. In case of immetropia, it is easier to understand. Okay, the same thing goes for hyperopia. So the 2.15 hyperopia is 2.8, 2.5 diopter, another hyperopia is 6 diopter. In this picture, it looks like a little bit different because 6 diopter hyperopia means approximately 16.67 centimeter away from the eye, and for 2.5 diopter, it means 40 centimeter away from the eye. But this distance is not real, is it? This is not real. This is beyond the eye. For optics, we can calculate something like that, but for in actual, we can I can tell you what is this. This is the position where we want to put our virtual object to correct the refractive error. Okay, so till now it's quite difficult to understand what is virtual object. If you know the concept of virtual object, then the refractive error correction we can define in another way. We can put the virtual object here so that we can correct 6 diopter hyperopia. We can put virtual object here so that we can put 2.5 diopter hyperopia. Actually, this is, but when we look from outside, and this is exactly like opposite, isn't it? 6 diopter closer to the eye and 2.5 diopter away from the eye. It's something like something different we feel, but it's completely okay. So it's 5 diopter, and in case of hyperbole, it's quite difficult, but I'm going to explain in next video why it is quite difficult. So this is the picture you have to understand in this video, because this picture gives you the clear idea how range of clear vision works and how hyperopia works. So see, range of clear vision is an 8 diopter hyperopia with accommodation of 12 diopters. See, 8 diopter of hyperopia, the patient has 8 diopter of hyperopia, but patient also has 12 diopter of accommodation. So see, this is the patient, this is the patient's eye. Okay, fine. This is the far point of an eye, which is basically hyperopic. Hyperopic means 12 diopter. 12 diopter means of approximately 8 centimeter from this 12 centimeter from this from the eye. And when this patient accommodates, let's take example, if the patient accommodated 1 diopter, 2 diopter, 3 diopter, 4 diopter, 6 diopter, and accommodate 8 diopter till now, then 8 diopter of hyperopia is corrected, isn't it? So this patient can see infinity with the help of 8 diopter of accommodation, with because this is hyperopic and the patient accommodated 8 diopter. The 8 diopter hyperopia corrects, it becomes now 0. The patient can see infinity. That's why we always struggle with hyperopia. We always try to do cyclorefraction and all this orthoptics examination and fogging and all these things. Why? Because hyperopia can correct is refractive error with the help of accommodation. So the patient can accommodate 12 diopters, and it uses 8 diopter of accommodation to correct his refractive error. And how much, how many diopters still he has? 12 minus 8, which is 4 diopter. So he can accommodate from here now 4 diopter to get clear vision up to here. And what is 4 diopter? 4 diopter means inverse of 25 centimeter. So the patient can see infinity and up to 25 centimeter. But if you put the object at 20 centimeter, he can't see because his complete accommodation is existed and it's impossible. But you have to understand far point, he stretches this far point to this infinity with the help of this 8 diopter of accommodation. And now he's remaining with 4 diopter of accommodation. So from 8 diopter, he uses his 4 diopter. See this picture? He uses his 4 diopter and his near point of accommodation comes here. So basically, if he is not an 8 diopter hypertropic, let's take an example. If he is emmetropic, so emmetropic means far point is always infinity, and near point with the 12 diopter of accommodation, it comes here like 8 centimeter or something like that, isn't it? With it, so but he uses 8 diopter to make his eye emmetropic here, to make his eye optically emmetropic. So he only can use 4 diopter of accommodation. So 4 diopter of accommodation, the near point is at 25 centimeter. It is very crucial to understand this concept. It is very useful when you are going to see your patients, and you can understand that why asthenovia happens there and why he's struggling with the distance object when it comes to patient is becoming more presbyopic as, and you can see that when 45 is around 45 50, you feel that in your patient that when he was in young condition he can correct his refractive error with the help of accommodation, but as time moves on the accommodation becomes weaker and weaker and weaker, and the manifest refraction is more on the plus. So it's very common in clinical scenarios, and this pictures explains why that happens all the time. And I want to tell you that in this all the pictures, see, it's a very beautiful picture. First picture is myopic, isn't it? Far point is here, example whatever is -2 or whatever, and the far point, then he accommodates this. So without correction, the range of clear vision in case of myopia is like this, isn't it? The far point is here, you cannot see infinity, and obviously near point is somewhere between this. And B is very ideal condition in emmetropic. Far point is definitely here, and near point till he can accommodate. And you can tell that range of vision from this to this is because of help of accommodation, isn't it? And third is low degree of hyperopia. In low degree of hyperopia, far point is beyond the eye, and from this to infinity, patient use accommodation to correct his refractive error. See, this is the point you have to understand. Patient correct his accommodation with the help of this, and after this infinity, patient to this point, patient use accommodation for clear vision. This is not a clear vision. It uses this range. Range is used, patient uses for correct refractive error. So in case of hyperopia, when hyperopic patients see for the distance for the infinity, see, this is very important point, just remember this. When patient sees the hyperopia patient view the infinity, at that point he always accommodate something like that. He has to accommodate. In this picture, for to see this patient, to view infinity, this patient must force himself for a diopter of accommodation. It is very necessary. That's why hyperopic patient always accommodate no matter what. For the near, definitely. For the distance, yes. So they always accommodate. That's why they feel asthenopic symptoms. It's very important to understand the optics, isn't it? For this picture too, let's again, I'm going to discuss about for this picture too. This is the far point, and he accommodates till infinity. To see the infinity, he has to accommodate, and to see the near point, everyone has to accommodate. That's why for a hyperopic patient, especially low hyperopic patient, they can correct their refractive error with the help of accommodation. That's why we always prefer cyclorefraction. Their cyclorefraction works magically. So to relieve this accommodation, because we don't know is accommodating or not, we have to do cyclorefraction for this kind of accommodation, which is very sustained accommodation. And this is the great case we have to understand high hyperopia. In case of high hyperopia, the far point, he pushes so much, but he cannot attain the refractive error. For example, let me tell you the example. Let's take example of this case. Let's say he is plus 12 diopter hyperopic, and he needs 12 diopter of accommodation to reach there, isn't it? to reach at infinity. But he has 8 diopter of accommodation. So he cannot attempt from 8 diopter of accommodation. He comes from here to here. But this 2 point is always lies beyond infinity. So he cannot see distance or near, doesn't matter. He cannot see this clear range of vision. This range of vision he cannot see there from infinity. So for this type of patient, he cannot reach there. So it's essentially important to understand this concept, that which hyperopia, myopia, metropia, low grade of hyperopia and high grade of hyperopia, in which case how much accommodation we need to exert or patient need to exert so that he come at least he reach to infinity. But sometimes if it is high hyperopia, patient cannot reach to infinity, so in that case glasses would help definitely. But if there is low or moderate type of hyperopia, patient himself correct his refractive error hyperopia with the help of accommodation. In that case we have to be more cautious as a clinician and as a student too. So you must remember these things. So let me please tell me in comment if you need another video. So this is the it. And again, with the reference, this is the great book to start. This is great book and my favorite of all time. And George Assimilis, Professor George Assimilis book is this is these three books is sufficient. Just try to go to these three books as far as possible. Okay, bye bye for now.